All right, hi. So the second part of this week is solving quadratics by taking square roots, which I believe we did do this before as well, as part of our quadratics unit. So the idea is to get x by itself, and then since there's just the x squared and we don't have a linear term, we're able to solve just by taking square roots, which is pretty nice. So to solve, just like any regular two-step equation, I'm going to go in reverse order of operations. So first thing I'm going to do is subtract the 6. So I'm going to end up with 9x squared equals 100. Now, next I'm going to divide. So since 100 does not easily divide into, or 9 does not easily divide into 100, I'm just going to leave that as a fraction, especially when dealing with square roots, because if you start estimating, we're trying to get exact answers here. We are not estimating with decimals, okay? So like on your work today, the multiple choices are going to be exact answers. So to undo a squared, you're going to take a square root. So on this side, we just get x. And the important thing to remember is that when you have something squared, you always have two answers. So, the square root x could be, the positive square root of 100 over 9, or x could be the negative square root of 100 over 9. Now, if you remember your perfect squares, you would know that 100 and 9 are both perfect squares. So this one's actually really easy to simplify because it's just 10 over 3 and negative 10 over 3. So I know that when doing these in the past, no matter what year it is, people always forget to make a positive and a negative. So just try and remember you're going to have a positive and a negative. Okay. All right, so this one. Same thing, I'm going to start by subtracting 2 on both sides. So I'll get 3a squared equals, oops, that's a 4. I do that all the time. Oh gosh, I just change numbers for no reason. And people will be like, Miss Thurman, why did you make that 4 into a 3? And it's usually just, well, because I wasn't being careful. Anyway, so 396. Okay, so one way to tell if something's divisible by 4 is first it has to be an even number, but if the last 2 digits are divisible by 4, which 96 is, then you know that your number is divisible by 4. It's just a little trick there. So when I divide by 4, I will get 99. So the next thing I'm going to do is take the square root of both sides. Now 99 is not a perfect square, so I'm going to break it down. I can't divide by 2, so I'm going to divide by 3. I'll get 33, and then I can divide by 3 again, and I get 11. So I have a pair of 3's and an 11 left over. So my final answer is going to be 3 on the outside because of the pair, and then on the inside I put 11. But also I have 2 answers with these, so my answer is also negative 3 square root of 11. So just try and remember that it's both positive and negative. Okay, so I think I have one more. Okay. Oh my. Sorry, that's almost knocked a bunch of stuff over. They're running around chasing each other. Anyway, so for this one, same thing. Reverse order of operations. So I'm going to add 1 to both sides. And then I'm going to get 6n squared equals 312. The only trick I know for if it's divisible by 6 is that it has to be an even number that's divisible by 3. So this is that. So if I divide by 6, let's see, that would be 52. Hopefully. Right? Yes, 52. Okay, so I'm going to take square root both sides. Now I've got to break it down. Break down that 52. So when I divide by 2, I get 26. Then I divide by 2 again, and I get 13. So I have a pair of 2s and a 13 left over. So in this case, n equals 2 on the outside and then radical 13. But also negative 2 radical 13. Ta-da! I'm sure that you all are so excited to be bringing back simplifying radicals. I actually really like it. It's always been one of my favorite standards to teach. That and exponents and logs, I think. Although I like quadratics too. I don't know. Anyway, hope you all have a good week. And, we're getting close. Just a few more weeks after this one. So I'm trying to make sure and ease you guys into whatever I can that was left over for the rest of the year.